Hello friends, my name is Tushar and today I'm going to discuss depth-first binary tree traversals. So what is binary tree? A binary tree is a tree where every node has 0, 1 or at max 2 child. So in this case, this is a binary tree. So there are three kinds of traversal on binary tree: preorder, inorder and postorder. Let's see what each of them means. So when I'm saying preorder, I'm saying visit left and right. So what that means is when I'm at a node, I'll first print out that node, then visit all its left children, print them, and then go to the right side and print them. And I do this recursively for every node. So let's start from here. So 10. So for 10, I first print out 10, then go on its left side and repeat the same process again. So for 15, first I'll print 15, go visit its left and then visit its right. So 15, I print 15 and go on its left side. So now I print 3 and then I go on its left side. I print 5 and then now I have nothing to go on the left, so I try to go its right. There is nothing on the 5's right, so I go back to 3. 3 doesn't have a right, so I go back to 15. 15 does have a right, so 6. So I first print 6, then 6 doesn't have left or right, so I go back to 15 and then I go back to 10. And then now I go to the 10's right and repeat the same process. So 30, first print 30, 30 doesn't have a left side, so I go on 30's right, so I print 2. 2 has a left, so I go and print 9, and then go back to 2 and then print 8. So this is my preorder traversal. Again, first print the root, then print everything on the left side and print everything on the right side. And you do this recursively for every node. Let's see what inorder means. Inorder is left, visit and right. So what it means is before printing the root, I'm going to print everything on the left side, then I'm going to print the root, and then I'm going to print everything on the right side and do this recursively for every node. So here, before I print 10, I'm going to print everything on the left side. So I go to 15. Before I print 15, I'm going to print everything on the left side. So I go to 3. Before 3, I'm going to go to 5. Now 5 doesn't have a left, so I first print 5. Then 5 doesn't have a right, so I go back to 3. So next, after everything on my left is printed, I print the node 3 node, and then I go to its right. There is nothing to print on the right, so I go back to 15. Now for 15, everything on its left is printed, so I print 15, and then I go to its right and do the same. For 6, there is no left and right, so I print 6. And then I go back to 15 and now I'm at 10. Now for 10, everything on its left side is printed. 5, 3, 15, 6. So then I print 10 and then go to its right and repeat the same process. For 30, there is nothing on the left, so I print 30 and then I go to its right. For 2, we have left, so we go to 9. So we first print 9, then go back to 2, print 2, and then go to 8 and print 8. So this is my inorder traversal. Again, first print everything on the left, then print the root, then print everything on the right, and do this recursively for every node. Let's look at the postorder. Left, right, and visit. So I'm saying is print everything on the left, print everything on the right, then print the root node and do this for every node. So we start again from 10. We have not printed left, we have not printed right. So first we go to left. Again for 15, left is not printed, right is not printed, so go to 3. Again, left is not visited, right is not visited, so go to 5. So let's print 5 first. 5 doesn't have left and right, so we will print 5. Then we go to 3. 3 doesn't have a right child, so that means that everything of left and right is done. So I will go to 3 and print 3. Then I go to 15. When I'm at 15, everything on the left is printed or visited, everything on the right is not visited. So I go on the right first. 6. 6 doesn't have left or right, so I print 6. Then I go back to 15, and then now for 15, everything on the left is visited, everything on the right is visited, so I print 15. And then I go back to 10. So for 10, everything on the left side is visited, but the right side is still not visited. So I go here to 30. For 30, left is not there, but right is there. So we go to right. So we go to 2. For 2, left is there. So we go to 9 and print 9. Then go to 2. Its right side is not visited. So we go and print 8. Then come back to 2. Now for 2, everything on left and everything on right is printed. So we print 2. Then for 30, everything on left and right is visited. So we print 30. And finally, for 10, everything on the left is visited, everything on right is visited, so we print 10. So this is the post order. Again, for every node, its left side should be totally visited, its right side should be totally visited, and then you should print the node. So that's a post order. Next, we will look at the code for all the three traversals. So here I have a code written for preorder traversal. As you can see, this is a recursive code. Also, I have a line number in front of the lines. So this is here. I'm going to simulate the call stack on the JVM, and let's see how this code works. So we start from root node, which is 10. So that gets called. So node is 10. So I'm going to write 10 here. Node is not null. So we are going to do is first print out 10 on line number 2. Then we are going to go to line 3, and there is a recursive call. So here I'm going to say that from line number 3 I went into a recursive call. So preorder node.left, so we go to 2. So we come here again, and this is 2 now. And again node is not null, so we print out 2. And then we go into the recursion again. So we'll say that from line number 3, for this 2 we went into recursion again, and we say node.left, so we go to 6. So again we go here. So node is 6, node is not null, so we print out 6. Again we went into the recursion from line number 3 for 6, and then say node.left. So 6 left is null, so we go here with null if node is not null. So here node is null, so it doesn't go into the if, so just returns back from this function back to 6. So line number 3 on the 6 is executed, so we'll execute line number 4 on 6, and that is node.write, so 6 write. So again that's null, again it goes there and does nothing, so it comes back on the recursion stack. So now we are done executing all the lines for node 6, so it goes back to its calling function, which is 2, and we execute line number 4 of 2. So here it says node.write, so 2 is right, so that is null. So we go here again, node is not null, so it doesn't go into the if condition, so it returns back. And now we are done executed line number 2 of line number 4 for node 2, so it goes back from there and goes to 10. And now for 10 we executed line number 4. And for line number 4, for 10, I'm saying node.write, so I'm going to go to 10's right, so that's 5. So 5 is not null, so I'm going to do is print out 5, and then calls recursion again with node 5's left, so I'm going to write 3 here, and then I'm going to go back into the recursion with 8, because that's 5's left. And then 8, again 8 is not null, so I print out 8. Then I go into the recursion again from line number 3 for node 8, and that node's left, 8's left is null, so it does nothing. And then it comes back to 8 and then executes node right, so 8's right, so that's line number 4, and null. Again null does nothing and comes back to 8. So we are done executing all the calls, all the lines for node 8. So we go back into the recursion and reach 5, and so we are done executing line number 3 of 5, so we execute line number 4 of 5. So we go to 4 and we say node.write, so 5's right, so 3 is my new node, and node is not null, so I print out 3, and then I go to 3's left, so from line number 3, so that's null, so I come back to 3 again. Similarly, 3 is right is null, so it will come back. So we're done executing all the 3 calls. So it goes back from 3 to 5. 5 is done executing all its things, all its lines. So 5 goes back to 10. And 10 is done executing all it calls, so it just returns. So this is my output: 10, 2, 6, 5, 8, 3. This is the preorder traversal for this tree. Next, let's look at the in-order traversal. So this is my code for in-order traversal. Again, I have the same tree and same call stack. Let's see how this works. So again, I start from 10, so my node is 10. Node is not null, so I go into the recursion in order. So I'm saying from line number 2, I'm going to the recursion again with node left, so I'm going to 2. So node is 2 now, node is not null. Again, I'm going to the recursion from line number 2 for node 2, and again node left, so I go to 6. Again, 6 is not null, so I go into the recursion from line number 2. In this case, it's null. So null doesn't do anything, it returns back. So now I execute line number 3 of for 6, and I print out 6. And then I go into the recursion again at line number 4. So again, that's null, so it comes back. So we are back to 6, and 6 is done, so it goes back to 2. So 2 executed line number 2, and now it's going to execute line number 3, which is printing the node data. So that's 2 got printed, and then we go on the right side of 2 at line number 4, and that is null, because root right, node right, 2's right is null. Again, null does nothing, so we come back from there and we go back to 2, and 2 is done executing all its things, so we go back to 10. So now 10 executed line number 2, so 10 is going to print out its data, and then we are going to execute line number 4 for 10. So saying node right, so 10's right. So 10's right is 5, 5 is not null, so it's going to go in its own recursion with 8. And so now node is 8. Again, 8 is not null, so it's going to go in its own recursion with 8's left, which is null. So now null does nothing, so it comes back from there. So 8 executes line number 3, which is printing it. And then 8 goes to its right, which is 4. So again, 4 is null. So it comes back from there. So then we are done executing all the lines for 8. So it goes back to calling function, which is 5. So we are back to place where node is 5. So 5 executed line number 2. So we're going to print 5. And then it's going to go in its own recursion. So that's line number 4. So in order, so that's 3. Nodes right, so node right is 3. So 3 is not null, so it's going to go in its own recursion. That is null, so it comes back from there, prints 3, then goes to 3's right, which is also null. 3's right is also null, so it comes back from there as well. So 3 is done executing all its things, so it goes back to 5. 5 is done executing all its statements, so it goes back to 10. And 10 is done executing all its statements, so it returns back to the calling function. So this is our in-order traversal: 6, 2, 10, 8, 5, and 3. The total time for both in-order and pre-order is going to be O of n, because where n is the number of nodes in the tree, because we visit every node. The size of the stack in the worst case will be the height of the binary tree. I'm not going to write the code for post order, but you can similarly figure out what the post order would look like. Thanks for watching this video.